After performing a tire rotation, or during new sensor programming, it may be necessary to perform a tire location relearn. This is done using the wireless right-left modify option. This is used on vehicles with an automatic TPMS relearn system. After entering in our vehicle's information, in this case, 2010 Dodge Charger, 3 options appear on our screen: Diagnose sensor, New sensor, and Wireless right-left modify. If required, the wireless right-left modify option is also available during new sensor programming. In this video, we are demonstrating the wireless right-left modify option after a tire rotation has been completed. After selecting the wireless right-left modify option, select manual right-left modify. The programmer is now ready to scan for the sensor ID number. Position it close to the sensor and press enter. The programmer will beep twice when it's successfully read the sensor's ID number. Press enter to select left or right, and press enter again to program it. Upon successful programming, the programmer will beep twice. Perform this procedure on all 4 wheels to complete the wireless right-left modify process.
Hey, welcome to another live Wells Tech training event. We are so happy you are here. Today we're going to be talking about DPFE.
Yeah.
That stands for Delta Pressure Feedback EGR or differential pressure. They mean the same thing.
Right.
Okay, delta means difference.
Yep.
Okay, so we're going to explain that difference today. What does that really mean? But before we get started, yes, we have the t-shirt giveaway. Yeah, okay. We got one up here. Wiring diagram again. What does this mean? What does this mean when you see that in a wiring diagram? All right, there you go. And it relates to what we're talking about today.
Yep.
DPFE. Okay, high failure rate on those guys.
Right.
Right?
Yeah,
and,
we used to see them a lot.
Used to see them a lot. We still see them around. They still fail. And knowing how the system functions is very important when you're diagnosing one of these.
Right.
And they're easy, right? If you get the code, what code is it usually?
A 401 typically.
401, yeah. EGR on a Ford.
Right.
Right?
Yep.
First thing you do is pop that known good DPFE that you have in your toolbox on there and see what happens. See if that light goes out, right?
Yeah.
But what do you do when that light doesn't go out?
Right. You got to test it.
Right. You got to know how that system functions, and that's why we're here today. We had one of those. And this one actually was a pretty easy diagnostics, but we're going to show you, give you some tips on how to make sure that the DPFE had failed, okay? So, but before we get started, let's talk about when DPFEs first came into existence. What was that? What year was that? 95 maybe?
Probably around there, yeah.
Somewhere in that era, right? And when they first came out, they were failing like crazy. And if you bring up a picture here, and you can see right there, that is an original DPFE that came off of Ford, right
looks
there.
Pretty corroded in there.
It does, and it had been on the vehicle. And what we did is we split it apart, and you can see that you have hoses on each side in each side of the case, okay? And inside of the case, there's a big diaphragm. Kind of looks like a toilet seat cover. Okay, and there are seals on each side, and what that would do, then that's your strain gauge, and that's where it would measure the difference between the pressures on each side of that diaphragm.
Right.
And what would happen then is that seal, because the exhaust gases are so corrosive, that seal would start getting eaten away, and that's why it looks so junky inside there.
Right, yeah.
Because the exhaust gases got in and started eating up the circuitry.
Right, yeah, that's no good.
No.
Also, during our research, we found that with the early model DPFEs, because that moisture from the exhaust gas would get inside that DPFE, Ford put into the computer's processes that they wouldn't run an EGR test under 32 degrees because they were afraid of it icing up.
And there you go. That's a great point, a great tip to remember is that, you know, if you're having problems setting this, you know, the drive cycle on that, what temperature are you at?
Right,
where are you located? You know, if it's cold outside, really cold, you may be having an issue.
Yeah, that could
there.
cause some headaches.
That's a great tip. Thank you. That's really good. Okay, and to show you, Wells actually designed a new DPFE circuit board.
All right.
And let's bring that up. There it is right there. There's a side angle of it, and you can see that we actually have 2 sensors on there.
Okay.
Okay, 1 for each side, and you measure the difference in there. And there's no way for the exhaust gas to get inside of that.
Okay, so it's a sealed, so it's not actually getting to the circuit board in there at all.
Right, it's not. And here, actually, I have one right here. And you can see right now, if bring up the next picture, that this is a picture of inside, how the board fits inside the cavity right there. You can see it fits just like that. We have 2 sensors on there now, just like that. And you can see that the pressures come in. There's no way for, and then they get glued to it, so there's no way for exhaust to get inside to wreck the circuitry.
Kind of
So
like
really
your
cool design.
your restaurant door analogy that you used.
Yeah, right. And you know, if you were on the other side of a restaurant door that swings both ways, you wouldn't be able to see me on one side, but you'd be able to feel how much I'm pushing, and I'd feel how much you're pushing, right? And this works the same way.
Yeah.
Right. We don't let the exhaust gases in.
Yep.
Right.
Keep that corrosive gas out of
Right.
there.
Keep it out, but we can tell how much pressure is on each side.
Okay.
And actually, everybody in the industry is now using this design.
It's a great
including
design.
OE. Okay. Yep. And that started at Wells.
Right. It cut down on failure rates too, right?
Right, oh, big time. Yep, yeah, lots more longevity. They still do fail. I mean, it's a strain gauge, it's moving back and forth and that type of stuff. Eventually they will fail, but they last a heck of a lot longer than the originals.
Right.
Okay, so that was big kudos to our engineers here at Wells for coming up with that. All right, so we're gonna talk about DPFE.
Yeah.
Why don't you lead us in there and let's talk about it.
So now that we know how this sensor operates, or we know what it's all about, let's pull up a wiring diagram and see how it works on the vehicle.
Okay.
So you can see here's our wiring diagram.
That's the typical one that you'll get.
Kind of hard to read.
It's a bit of a mess.
So there we go. We zoom in on it, and you can see that our DPFE sensor in the middle there, and it's listed differential instead of the delta. You can see there it's got 3 legs.
But it means the same thing. They are exactly the same.
Yep, it's got 3 legs going back to the PCM. But what I thought was interesting in this diagram, it doesn't list which one's power, which one's ground, and which one's signal.
That is correct.
So we had to go over what the sensor's actually doing to determine what wire was what.
But they're nice enough in that diagram to show you what that part is and what that part is doing.
Right.
Okay, and it's just like our picture back here. Okay.
So if we go back to that diagram, you can see that the coming out of the bottom of the sensor there, that's got to be ground.
Right.
That orange wire has to be ground. That's the way that sensor operates, being now I'm having a brain fart here.
Okay, well that does happen.
There we go, a variable resistor.
A variable resistor, and that's our drawing here. Yeah, you failed. You don't take your t-shirt off now. Okay.
Right, so that wire coming out of the bottom has to be our ground.
Yes.
So that would mean the wire the opposite of it, that brown and white wire there, that would have to be our power wire coming in.
That is correct.
And we always want to know what to expect when we're testing. Being that wire's coming out of the PCM, I would think it to be a reference voltage, a VREF, a 5 volt, 7 volt, 9 volt, something like that.
12 volt it could be too.
It could be too. So when we test that, we want to have an idea that it could be less than 12 volts. We're not expecting battery voltage there.
Right.
And then our brown and light green wire, that's going to be our feedback or our signal wire.
Our signal going back.
So
that's our little tie right here.
Right.
Right there.
So being that we know how to read the diagram, we're able to determine what leg of the wiring does what without the diagram actually telling us that.
Just by knowing. And that's why we teach that. We always look inside and see how things work and look at the wiring diagram just for this reason. Because when you do get a wiring diagram like this, you'll be able to know which wire is doing which.
Right.
Before you get to the car.
Right. What good is doing a test if you don't know what to expect right
there? Exactly right. Perfect. Right. Okay, let's talk about the system.
Yeah,
let's see how the system
we know how it
functions.
electronically works. There we go. We got the picture of the whole system up. We start in the upper left corner. There's our PCM. Then it controls we have wiring going to our DPFE and to our EVR, our EGR vacuum regulator.
And we have the wiring marked there now, so you know which wire is which.
Right. So our PCM is going to ground side control our vacuum regulator, and then it's fed just a standard 12 volt power through the fuse box. So if we ground that EVR, we could turn it on. PCM is going to ground that. It's going to open up that regulator, and it's going to take vacuum
Right.
from our intake manifold. It's actually when the PCM is controlling that regulator, it's going to create a magnetic field in there because it's using current, creates a magnetic field, pulls the pintle up.
Right.
That's the way it works internally.
Yep. Kind of like an injector.
Yeah, very
Fuel
similar.
injector. Very similar.
And it takes the engine vacuum from the intake manifold and transfers that vacuum to the EGR valve.
Right. And in turn, that opens the EGR valve. Then.
Right. And that, just as a side note, that control wire is pulsed by the PCM. It's not an on-off.
Okay.
And by pulsing it, it sends a certain amount of vacuum to the EGR valve to open at a certain distance.
It's like kind of like a peak and hold injector then, you know, where they can hold it at a certain point.
Right.
By pulsing it.
Right, yep. Because you wouldn't want to open that EGR all the way.
This is an early technology to do that. You know, it's not like it is today. Today it's very common to do that. This was very early.
Right.
But it was pretty cool.
Yeah, there's not even any wiring on the EGR valve, so that's why Ford uses the DPFE. It needs some way to monitor what the EGR valve is doing.
Right.
So, as you can see in our diagram here, there's an orifice, a small orifice that's in the EGR tube, and then there's a hose on each side of that orifice. They go back to our DPFE, and our DPFE is then reading the difference between those two hoses. When the EGR valve opens, it should see a change. It should see some sort of difference between those two hoses on the pressure.
And that ensures that there's actually flow
Exactly.
going from the exhaust back into the intake.
Right, and that's how the PCM is able to check itself to be OBD2 compliant. It's able to check the system.
Yep.
So if it's not working, say the EGR valve's not opening, it's plugged up, something's happening, it then would set an EGR code.
Which could be that 401. And that could be an EGR problem, that could be a DPFE, it could be the, you know, a million things.
Yep.
You know, that hose is, or that tube is broke, or the hose is off.
Right, yep, and then you could end up with poor fuel economy. If the DPFE were to go bad, poor fuel economy, it could run rough, check engine light for sure.
And don't be using garden hoses where those hoses are
Right,
located.
yeah, those are special high temp hoses. And go ahead.
Because it's, you know, the catalytic converter does get warm, and then you know, it's hot exhaust, very hot.
Yeah, and also commonly, make sure when you pull the DPFE off, you inspect those hoses. Make sure they're not melted. Commonly, those hoses will become melted if your catalytic converter is plugged up.
Yep.
Sending too much of the hot gas up there.
Or if they're easy to access, just replace them.
Sure.
You know, they eventually are going to fail.
Yeah.
You know, as the catalytic converter does deteriorate. Some.
Yeah, you know you have a good seal then.
Yep. So very good.
Yeah.
Okay. Anything else before we get to the car? What are we going to do on the car?
We're going to do a bunch of different testing. We're going to be able to test the EVR, the vacuum regulator. We're going to test the EGR. We'll test the DPFE. So that way, say the car just comes in and our car came in with a 401 code. If it comes in with that, we want to be able to verify that the other systems are all functioning before we replace the DPFE.
Okay.
That way we don't tell a customer it just needs a DPFE and could potentially need an EGR valve or the intake manifold's plugged up, something like that.
And the worst thing, and we always preach this, the worst thing that happens, the guy comes back in a month later, and guess what?
Yep.
They got the same code.
Right.
Now it's your code.
Yeah.
You bought
exactly. Yep. So now you could be buying an EGR valve or
That's
something.
right. Or whatever.
Yep.
Fixing the hoses. Geez, well, why didn't you catch that when you were doing the job?
Exactly. And like we talked about in our ignition coil class, you could do the caveman diagnostics, pull your DPFE out of your toolbox, swap it in.
Yep.
Hey, it fixed it, good, the car's fixed. But we always want to find a way to test. We want to find a way to verify before we replace any parts.
And ensure that customer is not going to come back with the same problem.
Right, yep. Fix it right the first time.
Fix it right. Try the best, you know, to get it down the road right. Otherwise, you are going to have to pay the price.
Yeah.
That's all there is to it.
Nobody likes to eat
And
parts
nobody
and
likes
labor.
explaining to the customer that I didn't do it right the first time.
Right.
So then why would I bring my car back to you next? Right?
Exactly.
Okay, so try to do it the best your first time, and it'll be better for your business.
Yep.
All right, so let's get to the car.
Let's go test it.
I like that part the best
All right,
anyways.
sounds good.
Okay.
All right. So here's our
Yeah.
02 Mazda Tribute.
It's a tribute.
So Mariner, Escape, same thing.
Yep.
3-liter V6 in here,
And it came in with a
401 code.
P0401.
Yep.
Classic EGR.
Yeah. Yeah, we see that all the
And
time.
the first thing you do, go to your toolbox,
Yep.
grab your DPFE and slap
that
it on there
test
and
drawer.
see if the light goes away.
Exactly, yep. So
But did it actually repair the problem?
Right, yeah, you
Could there be
wouldn't know.
something else that led to that problem? right?
Possibly.
Did you verify the system function?
Right, yeah.
That's what we're going to do
Yeah,
today.
you don't want that vehicle coming back.
Right, that's what we're going to do, is we're going to show you how to verify the system function once you get done with a job like this. And this is the best thing you can do for the customer and yourself, I think. Because when you get done, you can write on the bill that you had verified all the work and the system function. Okay?
Right.
So then, if this car would come back a month from now or 2 months from now and the guy has the same complaint of some sort, Mike worked on it, and now Brian's going to work on it, and Brian takes the work order and says, gee, it was all verified right here, and this is exactly what he did. It wasn't our fault.
Right.
Something else failed.
You have ammunition against that ever since complaint.
Ever since, yep. And that's what we're all about, and that's what we're going to do today, is show you a simple way you can verify it in just a minute.
Yeah, we can verify the entire EGR
Once
system.
you know how it works and once you know how to do it, it's very simple, very simple to do. It's going to take us longer because we're going to tell you how to do it as we do it.
Okay.
So there you go, tell them.
Well, let's start it off with the most simple thing. We checked codes first. So scan tool's already hooked up.
Okay.
So we'll just go over here and we'll check our engine data and see what our DPFE is reading.
Okay.
We'll go over here and you can see DPFE voltage right here, 5.1 volts. So our DPFE right now is supposedly reading 5.1 volts. We don't know if that's the computer, the DPFE, or wiring.
But it
that's
appears that the DPFE, that's classic DPFE failed.
Right, yeah.
So,
we would expect to see around 0.8 to 1.2 or so.
Right in that area.
Right in that area.
right.
Would be a good reading with just the key turned on.
Yes. Okay, so that's what we should be reading right now, but we're reading 5 volts.
So, and actually, just to kind of briefly go into it, on the computer-controlled circuit, the computer's actually sending that 5 volts out. So this could be for a open wire concern or an open inside the DPFE.
Yep.
So our first step, we want to verify that the computer's actually reading the right voltage from the DPFE. So grab our nice little acupuncture probes here from AES Wave, and we can hook up our meter to our signal wire and to the ground side of the battery. And we'll go ahead and back probe our signal wire, which we know from looking at our diagram.
Yep, and always have that there with you so you know.
Yep, so we're on brown and green right now.
And you're using, if you would be using a paper clip at this point, you would have just ruined that weather seal.
Yep.
It would be all over.
And we should be in there. So if we go over to our meter now, you can see 5 volts on the meter, 5 volts on the scan tool. We definitely have a DPFE
An issue with
problem.
the DPFE. So let's put a new one on there and see what we have.
All right. I'll go ahead, and we actually do have our new one already installed on here. And when we installed this one, we put new hoses on right away.
And that's a good point. That's a very good point. And when you replace one of these, please replace the hoses. Don't mess around with it. You know, for one thing, it gives you a chance to do a close inspection on them. If they have been getting hot, you have some sort of restriction in that exhaust, and probably a cat.
Most likely.
Or a cat starting to fail.
Yep.
And that's what caused this to fail in the first place. So pay attention to that stuff.
Yeah.
Take a close look
yeah,
at it.
ours weren't melted at all, but they were deteriorated. So.
Yep. And like I said, just replace them. Don't mess with it.
Right.
Just do it.
All right, so I do have the new one plugged in.
Okay, I'm going to go out to the other side.
Right, but we're still back probed on here, so we can see now that our voltage reading has changed. Go back over here, we're at 1.09, 1.09. Our voltage reading is right in spec now. That's where we want to be with the key on, engine off, or with the engine at idle, we should be right around there as well. Whenever the EGR valve is off, it should read right around 1.1 volts. So, we know our DPFE went bad.
Right.
We fixed the problem, but we don't know what the condition is of the rest of the system. We could still have a bad EGR valve. We could have a bad EVR, the EGR vacuum regulator. That could be bad as well. So now we can test those.
Yeah.
All right. So back to our diagram again. And like we talked about just before, the EVR, we'll start with testing that, has a 12 volt power wire here on the white, and I believe that was white and red. Yep, white and red wire. Should be 12 volts with the key on. And we'll back probe into there, go to our meter and verify. Battery voltage. Our battery's drained a little bit. We're at 11.75.
If we went across the battery, we'd see that same voltage or very close to it.
Yep. So now we know we have power there. Now what we can do is we can actually ground the solenoid and make sure it works, because that's what the computer does. It grounds it and it pulses the ground to open our EGR valve.
So when it grounds it, it runs current through the winding
Yep.
in that solenoid. That's all that solenoid is a winding of wire.
Right. Creates that magnetic field, opens up the pintle in there, and sends vacuum from the intake manifold to the EGR valve.
Yep.
Simple design. But actually, a strange thing that we came across, when you go ahead and ground this, and I'll do it right now, like if you were to control a purge valve or a vent valve, you might hear a click noise, or you might feel it actually move. This one you can't feel or hear anything. Got my fuse jumper lead here, and we'll go ahead and touch this to ground, and there's nothing. I don't feel anything here. I don't hear anything at all clicking.
And to be honest, when we first did that, we suspected it may not be working.
Right,
Because
yeah.
normally you'll get at least feel it. But this one is silent.
This one's silent.
And
So
you can't tell.
why don't you go ahead and start it up,
Okay.
and we'll just prove out that it's working. So when we go ahead and open our EGR valve at idle, I would expect the engine to run poorly, possibly even stall out. So why don't you go ahead and fire it up?
Okay, you clear?
Yep. All right, so we have a good idle. Go ahead and run our EGR valve on, and immediately the engine starts to run poorly, comes back, turn it back on, runs poorly again. And I'm gonna go one step further here. I'm gonna go ahead and back probe our DPFE signal wire again and show how that DPFE actually reacts. So I'm gonna ground our EVR again, make it run poorly, go to our meter, and you can see we're at 3 volts, goes back to our normal idle, open it back up, 3 volts again.
Very good.
Okay, so we just tested a lot of different things. You can go ahead and shut it off. Perfect. So by doing that fast test right there, we verified a ton of different stuff with one simple test. We verified that the EVR is able to create that magnetic field, magnetic field, and open. It's able to send the vacuum from the intake manifold to the EGR valve. The EGR valve is then able to open, the diaphragm's okay, send the exhaust gas, which isn't restricted,
All right.
into the intake manifold, which also isn't restricted because our RPM
Our
changed.
RPM dropped, right.
And then the DPFE was able to monitor and give a voltage reading on what it was seeing.
Right, so now we know that our replacement DPFE is working.
Yep.
We know that the system is functioning. The only thing that could affect it would be maybe the computer isn't grounding that
Right.
that EVR.
Right, and that
Right.
would take a road test to do that.
Right, we'd have to take that on the road.
Yep. Oh, and one other thing, if we saw our voltage decrease when we turned the EGR valve on, then we would expect to see that our hoses to our DPFE were actually swapped
Backwards,
around.
and that does happen. That is possible to do.
Right.
Okay, very good. So in a few quick steps, we're able to verify our job was
Right.
completed properly.
Right.
Okay.
And again, we have that ammunition against the ever since.
And when your customer receives that bill and he says he sees what you did, and it doesn't have to be anything, a wordsmith or anything.
Right.
Just put down in there what you did,
Yeah.
and everybody will understand, and the customer will be happier.
Yeah, we know the system is functioning as it's designed.
Correct. When it left here, it was functioning properly.
Right.
And we verified that.
Yep.
All right. Do we have any winners?
We do have quite a few comments here. Let's take a look.
Let's take a look at it.
Start over here. Mob City says potentiometer.
Mob City, my brother.
All
Thank
right.
you. And then you are absolutely correct. That is a potentiometer. I will accept that as an answer. You want to bring up my email, Glenn? There you go.
All right.
And if you
actually-
did answer the question properly, send me an email, and we'll get you out a shirt real quick.
And also,
And your shirt size. Put your shirt size and your mailing address in there.
Frank had a question. He also said potentiometer, and he had a question about our fuse jumper lead.
Okay.
He's asking, what size fuse do you recommend?
That's
Well-
a great question.
Right. Use whatever size fuse is normally to control that circuit.
Yes.
So in this case, it was and I don't know it off the top of my head, but we use a 10 amp fuse in here.
Because it was a 10 amp circuit.
10 amp circuit, right. So if you're doing a blower motor or something, you have a 30 amp fuse, use a 30 amp fuse in here.
Right. That's
You don't
what we do.
want to overload the circuit. You don't
Right,
wanna
you don't
use
want to
a
be under
bigger-
it either. You don't want to be popping the fuse. So
Exactly.
just use the same one that's in the circuit.
Yep.
That's what we
exactly.
do. Yep.
And that's what's
Perfect.
nice
Great
about this,
question.
is swap them in and out, and
Very
ready
good.
to
Right,
rock.
and then you don't have to worry. If there is something shorted in there, you're not going to start the thing on fire. And
Right.
I'm sure we've all done it. All of a
Melted
sudden,
wires
yeah,
and-
trying to get that connection off that battery as it's welding itself to it. You know, it
Yeah.
can be interesting.
Yep.
All right, very good, very good, very good. And I hope you enjoyed this class. I enjoyed this. I mean, this is one way that you can really, really help your customers and your fellow technicians.
And you can be confident in your repair.
And that's always a great feeling.
Yeah.
Okay, is there anything else you would like to add?
No, I think that's about
All
it.
right, good stuff. All right, we appreciate you being there. Without you being there, we would not be here. And we see you again next time in the Wells Tech Garage.
See you then.